Good evening, everyone. Welcome to this week's presentation of our xLights Gem series. This week is on Servos and Animatronics with Scott McCoy. With that, Scott, I will turn it over to you. Thank you.
Thank you, Andy. I appreciate that introduction. And just to throw this out there real quick, you've done a fantastic job this season with this program. I've learned a lot, and hopefully, well, I know everybody else has learned a lot. And hopefully, this presentation with servos and animatronics will be something a little bit different. And the reason I say that is because xLight is not really designed for servos. It can handle it, but it's really not a servo specific or focused type of software. However, you can do some pretty cool things with animatronics with it. So my background with animatronics started maybe 4 or 5 years ago, and right around COVID. And I wanted to just do something different. And while there were some basic animatronics in some of the shows, which were cool, I wanted to go a little bit further. And I said, I'm gonna try to figure this out because I just don't understand it. Uh, there were a couple boards that came out, and I started with those, and I've just been tinkering all the way through. So I say that to preface that I am not a servo expert or an animatronic expert, but I have learned a lot on my own, and I think there's a lot. It's fun. It's a little expensive, but if you're in this hobby, you expect to spend more than you really wanted to anyway. And if you want to get into some animatronics, whether it's basic or advanced, it's something that I've really enjoyed, and I'm going to be, even adding more to it. So I'm going to share my video screen so everybody can see this. And I'm going to pull up this monitor. So I'm going to give you if now Andy, let me know if you for some reason cannot hear the audio on this. But this is my primary animatronic, which is my Santa Claus, and he is essentially the host of my Christmas show.
Have you ever wondered how our show
It's
works?
very weak.
The show is made up.
It's very weak. Let me.
You should have a Zoom volume.
I'm gonna just do a screen share on it. Let's see. And then we'll make sure my audio. All right, Andy, can you hear this?
Have you ever wondered how our show works?
It's very low.
The show is made up of thousands of lights called pixels. We also use other
Do you have
elements,
shares?
such as
I guess you do have share
projectors and
sound set, but
animatronics. All
I'm sorry, Andy, say that again.
share sound, and you should have a Zoom volume.
Yeah,
I don't know why that's coming across so low. You got it turned up.
I don't either. Yeah. Let's see. Zoom
I don't know if it
volume looks
works
like
off
it's
your PC
on.
volume.
All right, I'm gonna crank it. Everybody hold on to your hats. Was that loud?
No,
Have you ever wondered how
that's
our
better.
All right.
That's good. Yep.
Have you ever wondered how our show works? This show is made up of thousands of lights called pixels. We also use other elements, such as projectors and animatronics. All pixels, other elements, and music are controlled by multiple computers and specialized control systems. Pixels can be controlled independently or together as groups of pixels. And when used together, they create some really cool effects. I'll show you how it works. Here is one pixel. Can you find it? It's right here in front of me. I can change it from white to red to green or any of 16 million colors. I can light up one element of the show, like the Christmas tree here on the porch. This tree has 150 pixels that work together. I can give the Christmas tree a special effect too, like this. Let's see this same effect on all of the trees. Oh, that's pretty. Even the luminaries are pixels. They may look like real luminaries with candles, but they are controlled by the show and give a realistic flicker, just like a candle. The fence in front of me has 450 pixels, all set in a grid. This is called a matrix. It can display some neat things, like this. Or even this. And when everything works together, it's Christmas night magic. That's how our show works. Want to learn more and see some behind the scenes of how the show is created? Just visit our website at McCoyChristmasLights.com. From the McCoy family and me, Santa, we wish you a very Merry Christmas and a Happy New Year.
Okay, so hopefully you get the gist of it. Obviously, this is going to be something that's a little bit more advanced, and the Santa was, like I said, it was about a 4-year, 5-year project, 4.5-year project of trying to get through it. So I'm going to share my, let's see here. I'm just going to leave it on that screen, I guess. The Santa that I used was a Walmart Santa. One of those, several years ago, they might still have them, I don't know, where he just kind of bounces back and forth with his hips and his arms move just a little bit and his mouth moves and his neck does a little bit of movement as well. Real cheap. It's like $100 or whatever it was. And I basically took that apart. So I'm going to show you some of the different elements. I apologize for jumping around here. I'm going to go back to my video and explain some of the elements that I use for animatronics. And put my little gloves on here because some of these are greasy and oily.
All we have is a black screen. Oh, there you go.
There you go. All right. You got that, Andy?
Yep.
Okay. This is a typical servo. It's a 25K. It's got some strength to it, some kick. It's 12 volts. And then, of course, this little head on it will turn. The head, you place a horn on it and affix it and so forth. And then that horn can move back and forth. It can go all the way around in some cases, depending on the servo. Some servos are 270 degrees, some are 180, some are 90, etc. Or I get the 180s, and then you can basically, stop it, give it limits. But whatever you can do with the movement of this horn allows you to control something. So in the head of my Santa, I've got a rod that'll go from this little segment here and it'll go over. So as this goes back and forth, it's got a pull motion and moves his jaw. So that's the general idea of how that works. There are all kinds of horns. Set a bunch of these out here. This is actually a linkage. So this would go here to do a direct linkage.
Scott, what
Another
does
one.
the K mean at 25K?
It's the strength.
Okay.
So, okay, so this is a 25. Then there's 35. So casing wise, they're the same, but it's got more kick to it. Then this one is a 60, and you can see the size difference. Kind of set those up like that. So a servo is a great way to really fine tune what you're trying to do. So in the Santa situation, I want the mouth. I don't want the mouth just to open and close. I want it to open halfway and then back or a little bit or full. I want the arms to go up a little bit or not. And the servo allows you to control any direction at any time from point to point. Takes a lot of programming and kind of figuring that out, which is definitely an issue. Takes time, just takes a lot of time. This is your typical servo controller for testing. Servos would connect to this, and then you can just turn it and say, see how far it turns and so on. Again, I'm not going to get super into depth in all the intricacies of this because there's so many different variables and things depending on what you want to do for your project. And this overview would just cover, some of the options. But I use this a lot because when you get a servo and you put the horn on it, then you have to adjust the horn in the center. So let's say it's a 180 and it goes from here to here. So I would do this, I would center it, and then I would control it with the board, put it into center mode so it's centered, and make sure it's centered here. Otherwise, it'll run, jam into the side, and then you'll end up blowing it. The X is on this one. The reason I wear gloves is because I actually blew this one, and it's bad. But then they start leaking grease and so forth, depending on how bad you destroyed it. So it's always good to have a board or something like this that you can just play with things and essentially get them set. When you mount servos, there's all kinds of mounts. Now, I will tell you, I'm new to 3D printing, and these are some of my 3D printed mounts that I've been playing with, and I am excited because mounting a servo is a pain in the quiotus. You really only have these connections up here, and in some cases, if it's not sitting flush to something or whatever, I'd used to have to put bolts and run a long bolt and stick it in and so forth because you obviously need to make sure you mount those properly. So 3D printed is pretty incredible here. Now, the other options for animatronics, and I use some of these in different things. So this is a typical, like a wiper motor type of motor. And this has a lot of kick, a lot of thrust. It does have stops. So what a stop means is you can actually set it to go to here and then go to here. These you'll see a lot like in a typical just waving Santa or something. And they would use essentially a motor. This is the same type of thing, just smaller. This is for Matos here, so you can kind of see it. And then obviously the mounting plate, you could take this off, put any kind of horn or arm on it you wanted. This one is only powered, so there are no stoppages to this. It's either going to run this way or it's going to run this way. That's all it does. You have smaller motors like this. So this is just a little 12 volt, but it's gearboxed. So the nice thing about the gearbox is this has a lot of strength to it. You affix whatever you want here for your horn or your arm, and you can lift things, wind something, make it pop up, do whatever you want to do. So that's that type of a mechanism. And then I use these quite a bit. This is what's called a linear. You see all that in there. You go. So this is called a linear actuator. This is the type of thing that the motor turns a rod here or a piston type of mechanism. It gets mounted. This gets mounted, and then it extends and comes back in. You can get these. These are very powerful. These are the things that lift TVs, out of a box or something, or lift them down from the ground. They're used in all kinds of stuff, big and small, and you can get them. I've got some. I just couldn't find one for tonight. I've got some that are like 3.5 inches. I mean, they're just teeny little ones. But you can use these for different things. And when you saw the Santa, the chair itself moved. He kind of turned. It looked like he was turning around, and that's actually a linear actuator that's just pushing and pulling the back of the chair, which rotates and gives them that illusion of rotating. Now, to control these things with xLights, you need a control board. Now, this is one of the Pixels to Servo boards. This is the one I started with. And I had a lot of problems. Those who've been in the room for a few years know that Santa had some spasms, and occasionally his arm would throw out and smack me in my jingle balls and whatever. And we just couldn't get it figured out. And it turned out, because I had a couple of these boards, it was the board. There was just a flaw in this particular version. The second version of this that Dave came out with is the Pixels of Servos uh, version 2, has a screen on it, has a lot of advanced features on it, and I've used that now as of last year, and it is really an awesome board. We've only really found one situation with it where it's just needs a little bit of a firmware update, but it's a feature that most people wouldn't use anyway. But the nice thing is with the new version of this, that and there's other manufacturers out there, not just promoting this one. This is just the one that I've had the experience with. But you can, I can on the board behind Santa, it sits behind Santa, is I can set those limits. So his elbow or his shoulder or something, I can set how far it's going to go up. That's 0 or 100%. And then back down would be 0. So when he's in the sitting position, those are all zeroed out, and the board handles all of that. So that's the way to go to make that work. All right. Oh, and just so I'll add this too. For a linear actuator, it's simply power. So you have to reverse power if you want it to go out or want it to go in, and then you would use another mechanism like this. So you can get them that are reversers, and this way it just triggers it. In some cases, so it'll just reverse obviously the polarity. I also use these a lot to do triggers and reverses, and you can get big ones and small ones and so forth. They're essentially just little relays, and you plug them in. Very, very handy. So I'm going to show you some of the other photos here. And again, this is just kind of a difficult topic to demonstrate since I don't have them out and I'm not standing in my garage showing you type of thing. All right. Let me get this up here. So I'm going to start back with my original Santa. Is that coming through, Andy?
Yes, sir.
I know I have a big screen. Sorry, everybody. So here's when I bought Santa. I gutted them because the mechanisms in these are just junk, little motors with rubber bands, essentially. And said, nope, we're going to reprogram this guy. I bought a chair. This chair was from a consignment shop or whatever, one of those type of things. And I painted it up. It looked pretty cool, kind of like a Santa chair, because I don't want him standing up. I want him sitting in a chair. That also gives me a resting position for his hands. So when I ripped them apart, you can see the arms here are, this is just padding with one piece of bendable metal. And then they had a little plastic piece that they hit. So when the motor turned, it kind of made the arms go up and down. So I affixed it directly to the back of the chair, and everything else just sits there to make it look complete, which he definitely doesn't there. So here he is with the stuffed body, everything else affixed, and the arms. Again, there's no real changes to the animatronic stuff yet, but I just want to get him in the chair and kind of looking right. I also use the Pixels to Things controller. This will directly handle things like the regular motors and the linear actuators. Now I'm going to show you a couple little things here that I use the linear actuator for, because I do get a lot of questions on this. This is an American flag. It's just an AC prop, but I don't like things showing in my yard. I'm just not a big put props all over the yard type of guy, and I like to try to hide it. If it doesn't look like a normal Christmas decoration during the day, I try to hide it. So in this case, the linear actuator is right up here at the top, And then when I get ready to turn this on during the particular patriotic song, it comes out perpendicular to the house. Nobody really sees that happen in the dark. And then boom, it lights up and there's an American flag sticking out there where nobody saw it before. And then, of course, the next song starts and that retracts. So it's another form, essentially, of an animatronic. This is some of the first attempts. I just did one arm and his neck and so forth, but I was playing with it. So I'm using that little test board we all saw, and I've got a handful of servos in there. There's technically one in his wrist. There's one for the elbow, and there are two for the shoulder because the shoulder can go out like it is there, and it can go up. So I'm testing the different movements. And in this case, I was putting dents in my wife's car. Here's the original Santa mounted with that servo box that I just showed you for the Pixels controllers. And it just mounts essentially in the back there. Now, some of the pieces to put Santa together, I started because, again, I didn't know what I was doing and I was just figuring things out. Is I would actually mount the servos into PVC, and that's what I would build the arms out of. And you can see here, I cut the PVC out, set it in there. Then I put some screws in and I fixed it. It was stupid. It's just not the way to do it. But I was essentially playing and trying to see what I can do. So this is how it would move. Again, I'll play that one again. It's pretty short. So you can see there's one servo here for the shoulder, in this case, again, getting started, and one for the elbow. Here, I have the same setup, one for the elbow. There's two here for the shoulder, and then, of course, a rotating for the wrist. Now, this is working pretty good generally, but see how they're not staying the same? They're being controlled by xLights exactly the same, but for some reason, the left arm is not. There you go. See it fell. And for 2 years, I struggled with trying to figure out what in the world is going on with this and why are they not? They should be exactly the same. I've replaced servos, I've done everything, and I just could not get it. It turned out to be just a flaw in the board. And here is the arm laid out. So this is the arm redesign. So now that I know a little bit more what I'm doing and controlling it, last year I redesigned the arm. So the elbow now looks like this. It's not built into the PVC. It's simply this is a dual. I can't think of the name of it, but it's a dual rotor. It's a dual piece. So these two this one's affixed to the servo, and then this is the one that turns. But it's touched or attached in two different areas. It helps give it strength and doesn't bend around on you. This works very, very well. So you can see I've got a 25 in the wrist. Doesn't take a lot of power or strength to just rotate a plastic hand. This one takes more because it's got to pull the weight of this entire piece of the arm. So it's a 35. And then when you get into the shoulder, it's a 60. Or I'm sorry, it's an 80. So here's the 35. Here's the 80. This is the lift. And then the rotate only has to be a 35. Again, the duals, they're mounted, and then this is the setup. So this is my current arm: rotation, elbow bend, lift, which of course is the hefty part because it's got to take all that weight, and then just the in and out. So this is just swinging the arm out. There's not really any lift on this one, so it can be smaller. This is the back of the neck. Kind of hard to see here, but I've got some other pictures. So this is just a 20. And because all this one does is rotate or tip the head down. This is what gives it its kind of a nod. There's another view of it, and it's kind of hard to see here, but it is connected on this bracket to another one that is sticking straight up. This one rotates. So the bottom one turns the head left and right, and this one here gives it the nod back and forth. Here's a little better look at it. And you can see where the plastic here, of course, is part of the original Santa. So I kind of had to use the base of what I had to use. So I've tried all different kinds of mounting methods, and this is just one of them, which happened to work because it's a hard plastic. And then same way there. So you can see where it affixed here, connected here, and so forth. Now, I will say that because he sits outside and does get some weather and some wind and all of that, he does get heavier. The head will get heavier if it's got a little snow on it or something. There are backup springs. So the nod does have a spring in the back of his head just to help with the lift in case so he doesn't fall forward like this. Without the spring, he'll just and no power. There's where he goes. This is the inside of the head. Obviously, you can tell where the eyes are here. I took the mechanism out that was there and reused it because it connects. I want to keep that. So I have a mount, sort of. And then I had to recreate all my mounting here. Now, if I would have had my 3D printer and knew what the heck I was doing, I would have built something for this and it would have been look a lot nicer than this situation, but it works. So here's the mouth motor. You can see the horn, and then it's just got this connection rod that comes down here to where the old one used to be, and then that moves the mouth and controls it. As you can imagine, the distance of this servo is very limited. It goes out to maybe here and then into here because the mouth does not have a lot of movement, and you don't want to jam it and break it. So here are some first tests. You can see the elbows in this case are the new elbows, but it's the old shoulders. But I've got pretty decent movement in it. Let me close these. And then, of course, after the elbow, making sure the new thing. I've already shown you this one. Then I added all the rest of the servos in there to do it. Now, it becomes very difficult. Let me share a different screen. It becomes very difficult to control anything, especially in xLights. And I'm not poo-pooing xLights because it's really not designed for this. But you can see here, this section, this is my Santa servos here. And this is how you control each individual servo. So the servo itself has a start value, has an end. This is whatever it is, mouth, turn, wrist, whatever. And it has a start and an end value to it, and then a ramp. The thing is I have to have an individual line here, layer, for each servo. So the servo is programmed on the board. That's going to be things like, is the down position 0? Is the up position 100? Or vice versa. Because if you put the left shoulder and the right shoulder both have servos mounted exactly the same, other than they're flipped because they're on the other side, right? So in one, when it's at 100%, the other one's really at 0, but they look like they're in the same position. So you have to program all of that out, get everything kind of leveled, if you will. Then you come in here and set everything up the way you want. So now the elbow or the shoulder, if I set it to 100, it's going to be essentially up in the air like he's waving. And if I set the other one, the left and or the right, to 100, it also goes up instead of down, even though the servo physically is is backwards. But they all have to work in conjunction. This is the difficult part. And thanks to Andy and some of the guys here who've made some changes in xLights over the last, I don't know, year or so, allowed me to give these labels and really kind of make this easier. But this is still manual work. And in normal servo software, you can just say, I want the arm to go up and the up, up to this position and wave and turn the wrist or whatever. I have to do each servo separately. So in one arm, it's 4 servos. Shoulder has 2, elbow, wrist. That's 4. So that means the second one makes it 8. So if he's going to bring his arms up and talk, that's 8 servos I'm controlling, plus the mouth, plus the neck turn, plus the neck tilt. I also have linear actuators on the back so he can lean forward and then, of course, turning the chair. So those are a little bit different. But in the servo case, a lot of times in the regular software, you would simply just create one ramp to bring the arm from this position to this position, essentially the end of the arm, like the hand. I want it from here to here, X to Y. And then it moves all the servos for you without having to do each one individually. Unfortunately, we just don't have that. Maybe someday, who knows? But it does work this way. It's just a little extra work. So this is my Santa explainer video that you all just saw, and these are all the Santa movements when you saw him do something. Obviously, the mouth is up here because that's all the main ones. All right, so let me get to. Oh, I want to show this too, just real quick. Sorry for all the jumping around. This is the linear actuator, and you can see it's a big one for that American flag because it does have some good weight to it. It does get a lot of wind. If it's windy, it does catch it, and it's got a long distance of travel. And then again, I put stuff up here just to hide all the mechanisms from individual people. Here is the current Santa. Obviously, it's changed a lot from what you saw. This is the box. Now, I will tell you these servos or pixels to servos boards are in their own boxes, but they are teeny. I'm not a big guy, but I can't get my hands in them. So I put them in a separate box. That way I can add more elements to it and different things and be able to work in it. Because you get a lot of servos, you're going to have a lot of wiring. This is the bottom. So the chair, it's 2 layers. The chair is sitting on the top layer and it's fixed. The bottom layer obviously is fixed to the ground. I've got these 2x4s are there for support. So when I transfer him around, it doesn't rotate and break the mechanism, but those are typically off of there. And then this is the linear actuator. This one's pretty small. It's only about 3/4 of an inch thick here and doesn't have a lot of throw, but it's just enough to make it turn 10 or 15 degrees or something, which gives me the effect of actually turning the Santa. Here's another look at it. One of the other big problems that I had, and it's something you'll have to consider when you get into animatronics, is it's not quite as simple as just throwing a pixel on a line, hooking into a controller, and going. They are very sensitive to power. You have to have the right power. You have to have the right amperage. And I started from the basics. I started with the wall wart type of thing. And then I did a bigger wall wart that was adjustable. And I just kept moving things up. This entire section of the board over here, it's under the sign, is all for the servos. And I built an entire system just to control the power for them. And if I'm lucky, I'll find that picture here. I can turn the power to the controllers on. I can control the servos with the master power switches. These all run into the pixels to thing board, so I can automatically turn these powers on and off. And the reason for that is a servo is always in the state of holding. You put a servo out there, so let's say his arm goes out. The servo has to hold it there. It doesn't just stop and have no power and freeze. If I turn the power off, everything goes limp. So it has to be powered. That takes a lot of power, a lot of juice, and some amperage. And it also heats up very, very quickly. If you keep that arm in the out position for too long, even here in central Illinois, when it's freezing outside, you'll blow a motor, blow a servo, because it just is not built to just sit there and hold it out there for an hour. And I had that problem too. So now I have a zero position or a resting position for Santa. When the show's over, or every sequence is over, it's called Reset Santa. He actually moves everything out. Everything moves just a little bit. The arms go out just a little bit. Come back in and put him in the zero position. The zero position puts his hands and his forearms on the chair. Therefore, the chair holds it. If he misses the chair, for example, if I didn't program it right and his arms miss the chair, as soon as I cut power, his arms fall down to the side of the chair. So I want the chair to hold it so it looks like he's sitting there, but not actually powering anything. So here's with all the different control, the servos, there's typically two power modes in a servo. A servo can be powered like with 12 volts or 8 volts or 6 volts, that type of thing. So when you have a large one, like a 60 or an 80, it's going to be a range of 6 volts to 8.4 volts. So you can be anywhere in that range. Obviously, doing it at the higher voltage gives you more power, but then the other ones would be, say, 6 volts or whatever. So in this case, I have some small ones here, 7.4 volts, 6.2, and then over here I've got 6.25. This is where I was playing with it, so these aren't right of what they should be set at. But you'd have I think currently it's like 8 volt and 6 volt or 6.2 or something, because different size. The wrist doesn't need as much power, and I don't want to blow it. So you have to have multiple power sources for that. These are also regulated, so I've got the regulators on them, and they're settable. This is nice, these little things off Amazon, because not only can I see the voltage that it's carrying on each servo, these show what they're set to, these show where they're actually producing, and then when he's running, this shows me the amperage that it is actually pulling. So there's all kinds of situations that this, again, took me a long time to kind of figure out because there's a lot to the servos. This guy, you've probably all seen this. If you're like me and you've already been through all the stores and saw all the Halloween and some Christmas stuff coming out, I waited last season for this guy to become available. He is Home Depot. He moves a little bit. The mouth does not move, but he has uh, the ability to look really cool standing with Santa. And he's already got some movement to him. So this is going to be I'll say this was my project for this season, but I don't think it's going to happen because of some other time constraints with some of my clients that I've got this year. But I will skin him. I will cut the mouth out. I will recreate the jaw in the mouth. He'll be servoed in the mouth so he can actually talk with Santa. I might play with the eyes to see if I can do that. But the nice thing is he stands there. He doesn't really need to move around other than the neck. So there's not a ton I have to do to him. Waited to after season, got him for like $50, and that will be my next project. And again, he'll go well with Santa. And if you remember, Santa sits on my porch. He's the host of the show. There's a little fence I have with the matrix in front of it. So all of the stuff that these guys mount on to stay there is all hidden. This is a look inside the box. Again, this is during a testing procedure, so I've got some other stuff hanging out there. But that box, everything feeds up through the back, goes into Santa. And he does lean forward. You're not really going to see that in any of these, but he'll actually there's a linear actuator in his back. See if you can see it here, right here to the right. That's a linear actuator. So he can lean forward as he's talking to you just to give him a little bit more of a realistic effect. Here is the box. This is the original one, first version that does have some of those issues. You can see how small and tight it is. It is almost impossible for a grown human to to get in there and mess with anything. So I highly suggest putting any of this stuff in a larger box. Oh, this is my pixels to things. So again, there's the box, linear actuator on the bottom. You can see the wires. There's two different power sources that run to him. With the power you saw, I do everything. All my power and everything is in my garage. I don't have that big of a yard, so everything is wired in the garage. I can also work on it then when it's cold, if needed. And so I set him here. Oh, here's actually a good. If you can see it, there's the spring, just to keep his head from falling over. And then I sit here and I program them. So that's what I've done with it. It's a matter of you've got the real simple stuff with a type of an animatronic where you can, you know, pop something out of the side of the house or up or you know, some of the basic stuff. Have Santa wave or have a coral prop wave. And those are great and those are pretty simple. And you don't really need servos for those. You can, but you don't need servos. You can just use any kind of a motor or a motor with the stoppages on the either side so it doesn't over rotate. Or you can get fancy and you can add servos to things. When you add servos to things, if it's a multi-prop servo like Santa's arms or head, you're controlling four at one time. And I will tell you, you will spend more time programming it than you do putting it together. It's just a lot of weird movement. Um, my next goal at some point when I get all kinds of money is there are sensors that you can purchase. I would reposition or remake his arms exactly as they are, but instead of servos, they're potentiometers that provide a reading. So this way I can actually hold his arms. This is how Disney technically used to do it with the audio animatronics. And then I can move the arms kind of like they do robot arms actually today. You move them to where you want, you make the movement, and it's recording the movement, and then it just dumps it and plays it back. And that would be a lot simpler, but I just haven't gotten that far. So for the most part, that is your introduction to servos, animatronics, linear actuators, and all that good stuff. And I'm happy to take questions.
Good, Patrick. Patrick, you're muted.
I couldn't unmute. Now I could unmute. You had
Oh.
it still locked. Is there nomenclature or like what's the super secret code for actuators on the speed that they go? Like it might be like a 3-inch throw, but somewhere in the model number or the description does it say how long it takes for that to happen? Because I ordered one and it's a 13-inch throw and it takes a minute and
Yes.
28 seconds.
Linear actuators are most definitely not fast.
Right.
So, and it'll say it on there. They go by millimeters per second is how they're
Okay.
rated.
MMP.
And so, like the one I showed you, which is a pretty big one, it's like an 8-inch, 8 or 9 inch or something. It has a max load, a big load on it, but it's only 14 millimeters a second. So yes, it takes a while. That's why the Santa chair has a small one because it's fast, but it's not powerful.
Okay.
But yeah, if you need speed of any kind, linear actuator just isn't going to do it unless you create a type of like a
Lever.
fulcrum and so
Yeah.
forth. You know,
Lever system.
lever system. There you go. Thank you. Yeah, yeah.
All right. Cool. Thanks.
Before Bob, we got a question in chat. Two of them. It says, do you have a video or pics of the linear actuator hooked up to the controller? And how do you get it to go forward and back? And I believe you showed that little box is the reversing.
Yeah,
Reversing
so
box.
right. So you can use the reversing box, but then that takes two ports. It's actually a really good question. Let me see if I've got it here right on my where the heck is it? So it- I use the Pixels to Things controller. That allows me to simply, activate it. And I'm trying to see if I've got it here. Well, I guess I don't. So in xLights, I have one channel of the Pixels to Things that is basically on and off. That's what powers it, gives it 12 volts. The other one is a flag or an on and off, whether it's reverse or forward. Right. So when you have the mechanism, the circuit, when the circuit is not activated, there's no power to it, the relay is going to give it normal voltage. Then, so if I turn the xLights on, it's just giving it power. If I turn the xLights channel on plus the second channel, which is reverse, then it powers that external mechanism that I showed you, the circuitry, and that reverses the polarity. So the on then is really reversed polarity. Does that make sense? So just think of two lines in xLights. When the on is on, it's going to do whatever. I mean, it's powered. The second one, when it's not on, it's forward. When it is on with the power also on, it's reverse. I know that's I probably didn't explain that very well.
Yeah. I use the same thing, linear actuators in our chicken coop to open the doors with a relay that reverses, right? So one relay
Yeah.
puts it one way, then goes down at night. The other relay kicks on, throws it the other direction.
Oh, correct. Right. So you've got to stop on it type of thing.
They stop automatically, right? They
Yeah.
at their extents, they stop by themselves.
Yeah. Yeah, it's power. One's always power, and it'll always power the linear actuator, and then the other one is just the reverse or forward.
Yeah.
But it takes two channels on the Pixels to Things to be able to do that.
Yeah. And do you have a link to that? I'm assuming he's referring to John. Are you referring to the relay board or the reversing box?
The reversing box, not the pixels to things.
Yeah. It's just a relay in a box, really. You know the boards with the little relays?
Oh,
You just
yes.
you just
Yes.
wire them backwards in there. One relay normally open goes, the wires go one way to common and then the other way, and that reverses the linear actuator.
Yeah. I'm going to share this on my video.
Yeah, those.
Yeah. So you can do them with these, but they're not directly designed for it. But like this one is, you can get it on Amazon. So it's a normally open, normally closed. This is the power. So right now, obviously, this one's going through. Then if this is powered, so Pixels the Things, I would power this. Then of course this one becomes closed and this one becomes open, and then that would reverse the power here. So it's forward, the power this, it's reverse. And these are just available on Amazon. They're pretty cheap. This one's an AC DC 12 volt. You can get them 5 volts. You can get them that run on AC. I've got a couple of these that run on AC that do other things, obviously, where you need AC on.
I just
But
put a
that's
link and I found that one I think that you're talking about in Amazon, so I just dropped it in the chat.
perfect. Thank you.
Yeah.
Yeah, it's a very handy unit to have for reversing.
Bob has a
The one you
question.
dropped in chat has more wires. I'm interested in which one Scott has.
It's got one extra wire.
I
Greg,
will.
Allie was first. They couldn't figure out how to raise her
Oh.
hand.
All right.
Yeah, sorry. I
Go
found
ahead,
it.
Alan.
Yeah, sorry. My question, Scott, incredible work, man. It's amazing to see. And the electronics there you had set up there in that picture where you're showing your voltage and all the power switches, I was nerding out there. That was cool.
Appreciate it.
Yeah, my question to you is for the servos, the rating on those servos are like 1 centimeter from center. How do you measure the torque on what you have, or and to make sure that A, it's going to lift, but also it's not under too much load and burn out?
Right. So the burnout part, I kind of had to figure out with the lift. And I'll be honest, I've got a box full of blown servos because it was just an engineering problem that I just don't understand and really didn't want to get into. So I would put it in there. I started with 25s and 35s, and because they're cheap, you can get them 2 packs on Amazon. And finally, I'm like, man, like the shoulder, it's just lifting too much weight. Plus, it's not direct weight, so I can't just weigh the arm because the arm's extended from the end. So that's more weight. And I just don't know how to calculate that because I'm not very bright. So I just kept upping them until I went, there we go. It's not struggling at all. And I went from the shoulders from 60 all the way up to 80s.
Love it.
And
It's
it
trial
was
and
just
error.
it was trial and error. It was literally because again, I didn't even know how a servo worked originally. And when I started getting into this, it was school of hard knocks, I guess. And I blew a lot of money doing it, but I learned a lot. My theory is now, if I'm going to do something, just make sure it's more than you think it's going to need, and you'll probably be okay.
Okay. That's great. Thank you. And just one last question too. I see the actuators and the motors, like the gearbox that you showed. Um, I'm guessing the pixels to things, those have drivers in them to allow you to just pass voltage zero and on. And do you just use a servo effect for that?
No, so the Pixels of Things board it can supply the 12 volts directly if you're using it on 12 volts. Or what I do is I use it just for the relay. So I will run. Let me see if I've got a picture of this here. I probably don't. But I don't like running power through the Pixels to Things because it just scares me of something happening. Let's see here. All right, share this screen. So here's my Pixels to Things. Again, you can't really see everything here, um, but you can see I'm using them as triggers because I'm not using both of the connections on them. And everything, of course, is ground. Now, what you can't see here is there's a board underneath it that has a bunch of those little boards that I showed you in my video here. That's what I use as relays to trigger whatever power I want. So so when I turn on a linear actuator, my pixels to things will trigger, say number 1 here. It'll trigger, and that triggers little board. Let me turn my video back on so you can see both of these. So then I've got this little guy, and he's got the power over here. Oh, I take that back. Power here, and then the connection here. So I can run 24 volts here or AC here and just have it basically be be a switch and switch it on and off. And this part's isolated from the pixels to thing on this side, and it runs to my device. So that's essentially how I do it. I don't run anything from the power from the pixels to thing board. And then this was my original reverse. I use these as the reverse because you'll need two, just like this. Essentially, this is set up like that. That's the exact same thing. Other than some of the wiring on this one, is a little fancier, but these two are identical. They will operate identical for reversing.
That's
Did
great.
that answer your question?
It did. And just the last part, what effect do you use inside xLights to actually trigger that voltage?
Oh,
Or
yes. That's just an on effect.
it's just the on effect. Okay.
Yeah.
That's
For
great.
the
Thank
pixels
you.
of thing, it's just an on effect. Yep. And you can ramp it too. You can do ramps on that. But again, I don't do that because I'm triggering relays. I'm not changing a bulb or something.
Binary. Yeah.
Okay. Any other questions?
Bob has one.
Yeah. Hey, Scott, as you know, I'm using a different controller.
Yep.
Have you found that the voltage level makes a difference in the jittering of different servos?
It does, but it's going to be more of the amperage. And again, I learned that one the hard way. I've probably bought, I don't know, 10 or 12 different power supplies. It really came down to as long as you're in the servo range. So a 60, so I still have my camera on, right? So this 60 here is 6 to 8.4 volts. That's its range. As long as you're in there, you won't have jittery other than the amperage that's supplying it. And that's where I really kind of had to wrap my head around it because that was difficult to figure out. So if you're having jittery problems, you're talking about jittery like it's just sitting there or it's just trying to move. It's jittery. It's not actually flying back and forth, right? It's just a
No,
jitter.
no, I'm talking about, you tell it to move, and instead of being a nice smooth from 0 to 180, it's jittery getting there.
Okay. So on the board, or this would probably be in your settings. So everybody's aware, Bob's got a different board from a different manufacturer. The settings I told you on my board that has a little screen and I can set all this stuff, he can do with his board by software, and which is fine. I don't necessarily think it matters too much one way or the other. But you have 1 or 2 nanosecond steps. What it was called a 1 or 2 step, and that step is how big of a jump it takes. So if it's going to go from 0 degrees to 90 degrees, it's X number of steps, say 90. But if you have it set to 2, it's actually going to do 2 steps for every one. It's faster, but it's not as powerful and it's not as smooth. The issue that I found is if I don't set it all to 2, or I mean to 1, then it is I just had problems with it. And that's what's called the pulse width.
Yeah, I went from 8-bit to 16-bit, so I get the whole pulse width, and I'm still having a little bit of. I found I've had to drop the voltage. I'm using buck inverters like you are, and
Yep.
found I've had to drop the voltage to get that jitter to start going away.
Well, check your amperage because the voltage really shouldn't matter.
Okay.
It really shouldn't.
Okay, I'll look at that.
Yeah. So I run all of mine just under max. So if it's 6 to 8.2 or 8.4, which is what a 60 is, I run mine at like 8 just to stay under it a little bit. But then I never have to adjust it. But I did have to go back to new power supplies and figure it out to make sure it was really an amperage problem, which is why on my board I have those little amperage deals. I was surprised how many amps. I mean, it was pulling a lot of amperage.
Okay, yeah, because the cult board I'm using, it gives me voltages, but it doesn't give me amperage. So I'll start looking at that.
Yeah, and make sure your pulse width is matched in xLights too.
Yes, that it is.
Yep. Because that'll definitely cause
that
jitters
caused me
yeah.
all kinds of headaches.
There's a lot more to it than most people think. There's a lot more to it than I thought when I got into it, and I'm still learning. But yeah,
Well, I do like the fact that the board I'm using on the board itself, I can set the minimum range and the maximum range where you're going from like 0 to 360, I can tell it, okay, no, I want, even though I got a 360 servo, I can say I want you to go from 90 to 180 and be done with it.
Right. And I can too, but it's on the board.
Yeah.
So most servos do not travel, just so everybody's aware, they do not travel the whole distance they're capable of. So if you have a 180, it may be really 72 to 104 or whatever you want it to travel. And then once you set it on my board, xLights sees those settings as 0 to 100, which makes it super simple because you'll never go past those ends.
Yeah, overdriving a servo is bad. I've burned up too many of them that way.
Right. Exactly. And it also just makes it easier to program. I will say now I've not used Bob's board, and it looks cool. I need to get one just to play with it. Having the stuff on the board, having those settings and things on the board, to me has a little bit of an advantage to it because I can set all of that directly on the board. So remember when I talked about my screen share or my video? Yeah. So I talked so I showed this, and this is my controller. So I can get my servo set up, put the horn on it, and then say, okay, this is centered. Yep, it's right where I want it to be centered. Wherever in the world that is, it's centered. Then I go, okay, here's the extreme I want on this side. Here's the extreme I want on that side. The board, the new version of this one, version 2, will let me do that electronically. I can actually go on here and adjust it, and it'll go. So it is this board too. Then when I get it exactly where I want, oh, the arm's up here, that looks good. Then I go set, and that's my extreme end on one side limit, and then the other limit when I set it. And I do it all from the board. So I don't even have to be connected. All it needs is power, and I can do all of those settings, which to me is handy because then nothing has to be in the software itself. It's all in the firmware of the board. But it's 6 one, half dozen the other. Just they both work the same generally.
I'll have to look into that. That's cool.
Yeah, it's just one of those things I like that I can just power it. I don't have to have it getting data.
Oh, cool. Well, thanks, Scott. That was good. Formative.
Thank you. I do plan it's probably won't be this year just because I'm busy, but my next animatronic project, which will be that reindeer, I think just to kind of help everybody out. And I wish I would have done this more. I took a lot of pictures, but I might just kind of video the entire process and put a video together that you guys can share.
That would have been fantastic. Thanks again. Thanks, everybody.